Hello and welcome back to day 2 of the Web Indicators Summer School. This is the practical day, and this is part of a series of presentations that talk you through the workshop tasks. Please download the presentation files, instructions and data from the file shown on the slide, from the folder shown on the slide, and use these presentations as introductions to the workshop tasks provided. I just want to start by reminding you of the metric triad principles for using altmetrics. These were not mentioned yesterday, but are an important thing to bear in mind when you're using indicators, any type of indicator to help with research evaluations. So the principles include robustness, making sure that you're using the best quality data in terms of accuracy and scope. Humility, recognize that whatever numbers you produce should only support expert assessment but never replace it. The numbers are never good enough to replace the opinions of an expert. Transparency, make sure that if you're using the numbers to evaluate anyone, then all aspects of the process should be as transparent as possible, from the data collection to the formulas. Diversity, accounting for all types of variation by field and using a range of indicators if appropriate to reflect a variety of different types of impact and researchers. So this might include multiple altmetrics. Reflexivity, recognizing that as soon as you start to measure people, their behavior will change. So any type of evaluation system using indicators is likely to impact on those that are assessed. And the full report is here. So in these workshops, we're going to look at gathering raw data, calculating indicators, applying Mendeley, reader counts, and applying web indicators. And we're going to use the software Web Metric Analyst for these. The processing stages come in 4 parts. Firstly, we're going to get the publication metadata from the Web of Science in this presentation, but you might also get it from Scopus. There are instructions in the back of the workshop handout. Dimensions or somewhere else, you might already have them. We're also going to make web queries if we're doing web searches for alternative indicators, web metric type indicators. And we're going to submit queries to wherever they need to go, Bing for the web metric indicators, or Mendeley or altmetric.com via Web Metric Analyst to get the indicator scores. And then we're going to calculate the indicator values and confidence intervals with Web Metric Analyst using its reports function. And these are the 4 stages that we're going to go through, some or all of these for each indicator. So workshop 1 is going to look at gathering the raw data, in particular downloading sets of Web of Science articles and the structured file naming format. I'm going to go through how it works at the University of Wolverhampton, and you'll need to modify these instructions for however you access the Web of Science from your institution or from your home computer. And if you're using Scopus or Dimensions, then you'll have to modify the instructions to cope with the different ways that they work. We're going to look at stage 1 of the processing stages, downloading sets of Web of Science articles. This workshop covers all stages from gathering the data to calculating the indicators. Gathering sets of articles from the Web of Science or Scopus or Dimensions is often needed for the world normalization purposes, even if you already have a list of articles to analyze. And we're going to look at a case study of Spanish chemistry of alcohol research from 2012. And we're going to try and answer the question, did Spanish chemistry of alcohol research in 2012 have above average impact? We're going to get our publications from the Web of Science. And remember, your Web of Science might look different and you might be using Scopus or Dimensions instead. If you're using the University of Wolverhampton, your approach will be different. If you're not, then we have a library resources page which lists all the databases, and the Web of Science is there. So we scroll down and click on the Web of Science to access it. We need to select Web of Science core collection. If you look at the drop down box on the right, the process doesn't work with all databases. We have to select Web of Science core collection. Without that, we can't save the citations we need for the analysis. And then in the Web of Science, click on the advanced search. The tab at the bottom of the screen shows the advanced search selected. So it doesn't work. The thing that we need to do doesn't work in basic search. We need to switch to advanced search. We're going to ask the Web of Science for a list of publications on alcohol from Spain, published in 2012, from the subject area of chemistry. So SU equals chemistry, that's the subject area. TS equals alcohol means the topic contains alcohol. AD equals Spain, the address field contains Spain, so the address must mention Spain. And published in 2012, PY, publication year is 2012. So we put all of these into the advanced search for the Web of Science and click search. We also have to select all languages and article. So we're only going to analyze articles and not other document types. This is important for the field normalization because different document types attract citations at different rates. In our copy of Web of Science, you get a table with the number of results in, and when I ran this query I got 249 results. You might get a slightly different number. If you click on the 249, it takes you to a list of the results. Here's a list of the results in the Web of Science, University of Wolverhampton copy. And if you just quickly eyeball the results, you can see these plausibly look like Spanish chemistry of alcohol research articles. It's always worth having a quick look just as a quick check that nothing obvious has gone wrong. You've not done anything stupid like I do a lot. The next thing we need to do is to save all the results to a file on our computer so we can do lots of processing on it. And to do this, in the Web of Science, click Export, then select Save to Other File Formats from the drop-down list, and make the choices below in the dialog box. So you need to select Tab Delimited Win UTF-8 as the file format, request the full record, and enter the first and last record number, the bits pointed to by the blue arrows, and then click Send, and the Web of Science will download the information you need on the articles matching the query to your computer. Once it's done that, I'd like you to rename the file that's saved to chemistry space alcohol space 2012-Spain. The original file name will be something like savedrecords.txt, and I'd like you to change the savedrecs bit to chemistry alcohol 2012-Spain. If your computer hides file name extensions, then that'll be the name. If it shows you file name extensions, then keep the .txt at the end. Why give it a special name? Well, two reasons. Firstly, to track what the data is, because we'll have lots of files. And secondly, there's a standard naming format which will enable Webmetric Analyst to process the files seamlessly. And if we open up the file, you'll see something like this. Columns of data about the publication type, the authors. One of the columns is citations. It looks like a jumble, but it's all the data that we need from the Web of Science. And now we're going to get a second file from the Web of Science, and some Spanish chemistry of alcohol research is in the category biochemistry and molecular biology. So we're going to repeat the above steps, but change chemistry to biochemistry molecular biology. So this is our new query. and save this in Web of Science again and rename the file biochemistry molecular biology alcohol 2012-Spain.txt, or if your computer hides file name extensions, leave off the .txt at the end. And remember, change to article type for this one. And now we're going to get world reference sets. We're going to compare Spain to the world. And for the world reference sets, we repeat the first query but without the Spanish address part. So delete the and AD equals Spain and then submit the query again in the advanced search tab. This gives 5,917 results, or it did when I tried it. But the Web of Science only allows 500 to be saved at the time. So save the middle 500 to give us a date balance set from the middle of the year. And call the file chemistry alcohol 2012-world.txt. So it must end in world so that Webmetric Analyst knows this is the world reference set. To enter the middle 500, when you get to the dialog box which asks you for the first and last record, you have to work out roughly the middle 500 records. As long as this is approximately correct, it shouldn't make much difference. Otherwise, the options are the same as before. And then do the same for the middle 500 results for biochemistry, molecular biology, and rename that file biochemistry, molecular biology, alcohol 2012-world. So at the end of this, you should have 4 files with matching file names, a Spain and a world version for each file name. The file names are now following the structured file name format. It's very important that each file name contains a hyphen, and following the hyphen we get either the word world or another world. In our case it's the word Spain. So the one on the right is the correct naming format. 1 hyphen, all the rest spaces. This naming format signals to Webmetric Analyst which is the world reference set for each sample. Essentially, that's all it does. And it does it through the hyphen. Hyphen world is the world reference set. And if you have multiple groups, you can give them all different group names, but the group names need to match. So all the Spanish groups need to be called exactly Spain. If you call some Spain and some Spanish, then that will produce 2 groups, 1 for each name. Here's another example. Is lots of different fields, 3 different fields, but 4 different sets, 3 funders and the world, NIH, MRC and Wellcome, and lots of different years, 2013, 2014, 2015 and 2016. So we have huge numbers of sets, huge numbers of files, and they come in sets of 4, a world reference set and 3 funder sets for each combination of field and year. And this is fine. Webmetric Analyst will recognize what they are, how they relate, and process the appropriate indicators for each one. So workshop 1 involved downloading files from the Web of Science and saving them in the appropriate file format. So please have a go at this now before you go on to the next presentation. Follow the workshop instructions and switch them to Scopus or Dimensions if you prefer to use those databases instead.